Welcome to Digital Works TV. I'm Steve Johnson. My guest today is Tamia Neal. She is working on her master's degree at UAH, the University of Alabama in Huntsville, in systems engineering. Is that as hard as it sounds? Go ahead. You can say it's easy if you want.
I think it's a bit more difficult than other discipline engineers may think.
Okay. Well, we're going to talk about now, but I want to go back to your background a little bit. So you grew up in Montgomery, or in the Montgomery area. Went to Enterprise High School.
Yes, I did.
So I guess you grew up in Enterprise.
Yeah, I grew up
Okay,
in Enterprise.
okay, and went to Enterprise High School. Were you a good high school student?
I was a good high school student. I took mostly AP classes,
Okay, so
graduated honors.
so you could have majored in a lot of things. Heck, you could be a philosophy major, but you chose to major in engineering. Why did you do that?
I've always been good at math and science. I'm better at math, but
That puts you in a very small
yeah,
percentage of the world.
I've always liked math. So
Okay.
I was just looking at different careers that involved math and science and STEM. So,
Okay. Did have you found that you need now your bachelor's degree is in industrial engineering?
yes.
Okay, did you find that you needed to be good in math to do that?
Not necessarily. Like, I'm not doing calculus in my everyday work or in my. I have to take calculus courses,
Yeah.
but in the work that I'm doing, I don't do any advanced math.
Okay, so my sense of it is when you graduate from high school, like everybody else your age, you were computer savvy.
Yes.
So and I have you found that you darn sure needed to be once you got to college.
Definitely needed to be. We have some for engineering students at UAH. You take an intro to engineering course, and so you have to learn how to code with like Python and MATLAB. And there are other courses where we do simulations, and knowing how to use different programs is definitely
Okay, so it just
important.
and this is more my curiosity than anything else. Math or computers, which one did you need to know more of to get a bachelor's degree in industrial engineering? It could be a tie.
I wouldn't say it's either or.
Okay, all right, but you had to know, pretty much had to know both then.
Yes.
Okay. So you got your bachelor's degree. I'm sure your parents were proud. And then you said, I'm going to go on and get my master's degree.
Yeah, I'm gonna keep going.
So what are you getting your master's degree in?
In systems engineering.
Okay, so we'll talk more about that. But you're working on your master's thesis right now, correct?
Yes, I
and
am.
that is in what?
My thesis topic is about systems integration and how we can improve that using modular design concepts.
Okay, well, more computer than math for that, right?
I'm using both.
Okay. So I would not have a career in either one of those then. Okay, so you got your bachelor's in industrial engineering. Why did you decide to do systems engineering? Is there it just did, or did somebody talk you into it, or did you just decide to do it?
Well, I had started off college freshman year undecided on which engineering major I wanted to do.
Okay.
So I was just taking general math courses. I wasn't taking anything specific to any engineering. But then I thought, okay, I can do mechanical engineering because people say that's very generic. You can do a lot of things with the mechanical engineering degree. But as I was taking those courses, that kind of math was not my strong suit.
All right.
Was not good at, like physics is not my strong suit at all. So during freshman year, they have this course where you can learn about all of the different majors.
Okay.
And so they had different professors from the different departments kind of promote their department. And I saw the industrial and systems engineering one, and that was more my speed. So, okay, I can
why
do that.
was it? Why was it? Well, you made it sound like it doesn't require quite as much math, but am I correct that an industrial systems engineering major, and that's what it was, correct? But
Yes.
so we'd kind of be looking at things in a broader context.
Yes.
Is that right?
In a broader context and in a more managerial context,
Okay.
it's the industrial part is about managing plants and like manufacturing, and the systems is we have these components and things, but how
Yeah.
did they work together?
Okay. And you're wanting in your master's thesis, am I correct? You're wanting to take multiple systems and put them together. Am I understanding it at all?
Not necessarily multiple systems. That could be, it could be done. What I'm doing right now is not limited to just components. But what I am focused on right now in my thesis is taking different components and parts and putting them together into one system.
Okay. So majoring in industrial engineering, which I'm sure wasn't an easy major, working on your master's degree, uh, is this work or fun? Or is it fun that requires work? How would you describe what you're doing and what you've done?
I would say it's work that's fun. I'm not particularly zoned in or interested in a singular topic. Like a lot of, I would say, aerospace majors, they either want to be an astronaut or they love planes and jets and rockets. But I'm not like that. I don't.
So does it just interest you doing the actual engineering to solve problems?
Yes.
Is that what you like doing?
Yes, that's what I like doing. And I think that's why I'm doing this topic, which my advisor, Dr. Thomas, he
Dr. Dale Thomas. We're going to talk more about him in a second.
Dr. Dale Thomas, he suggested that I do this topic because he thought it would be a good fit for me.
Okay, so when the systems engineering, I have yet to talk to a systems engineer that didn't seem to be very enthusiastic about systems engineering. Mm-hmm. Do you find yourself being that way? I mean, you're working on your master's thesis.
Yeah,
and I think that's a pretty serious thing. But not being an engineer, it's like I have a little bit of a hard time relating to it. But is it when you're working on your thesis to things like, wow, that's cool. I like that's cool moments.
Yeah, especially working on my thesis is very different than undergraduate and just taking courses. You don't get that much experience actually applying the things that you're learning. And so that's why I think graduate school is really good.
So you're applying things you've learned.
Yes, I am. And at the start, I had an idea, but I didn't know what to do with that idea. And as I just keep working and I find something new, it's like, oh, I'm so happy, yes, that works. Or like, oh, this is not helpful at all. So the fun parts are when I've been struggling for so long to find something, and then I finally find that thing.
Okay, so, engineering students, I mean, you're hanging out with other engineering students in many cases. Do most engineering students like what they're doing? I mean, is it a major that you couldn't do if you didn't like it?
I don't know why you would do engineering if you didn't like it.
Well, there are people who, I think, I might be misstating this, but get degrees all the time in business stuff where they're, I don't really like it, but I'm going to go to work at so-and-so and I need this to be able to, but the actual becoming an engineer and learning engineering stuff appeals to you and your fellow students?
Yes.
Is that unique to engineering, or you just think,
I don't think it's unique to engineering.
But it sure seems to be something that engineers share.
Yes.
Okay.
I could be a nurse if I just wanted to be a nurse, but I don't want to be a nurse.
You want to be an engineer.
Yeah.
Okay.
Yeah.
Now, in systems engineering, so is model-based systems engineering is part of what you do, correct?
Yes, that's my focus also.
Okay, so when you're doing, and so everything's digital, and you know, you've got a model. Are you doing your own modeling?
Yes, I am.
You're doing your own modeling for a system. Are you also doing the system itself, the larger system that the model is modeling a part or segment? Are you doing all that yourself?
Yes, I'm doing it myself.
Okay, so that would seem to me to be kind of a real kind of education, seeing the big picture and the little picture kind of at the same time.
Right.
Is that fun? Or would you rather somebody else was doing the modeling?
I'm a part of a research group, so there are other graduate students, master's
Okay.
and PhD level, and they also model. And I reach out to them and ask them, because their degree focuses are not just systems. Some
Yeah.
of them are aerospace and mechanical, and so they have a better understanding of how the system functions. And so I'll reach out to them and ask them, okay, how would you model this?
You know, one of the things that I've been told by many people and modelers, that what they love about it is there can be more than one way to do something. Do you find that, is that one of the things you like?
It's not necessarily something I like. It is important to represent all of the different variations, but
But you want to get to the best.
yeah,
Best
that's the.
Is there a best variation every time?
No, it just depends on the person who's doing the modeling and
Yeah.
then the people who have to interpret that model.
Okay,
And that's the difficult part, is finding that balance.
So I guess what you're saying is, yes, there could be more than one way to do this. That's a good way.
Yes.
Okay, which when you look at an airplane, I have a hard time getting my mind around the fact there could have been a better way to do something in the engine, or another way to do the same thing. But that's true, isn't it?
Yes, that's very true.
Okay, so now Dr. Thomas is leading a project at UAH developing nuclear thermal propulsion under the auspices of NASA to be used if we went to Mars, or if we're going flying anything to an outer planet, somewhere where you've got to go long distance and you need to carry enough fuel to go there and back. So you're part of that project, aren't you?
Yes, I am.
And am I right? He had told me that. Are you a modeler for that project? Are you modeling?
Yes, I am modeling. I'm personally not modeling this system. There are other people in our research group
Yeah.
doing that, but I'm using their models for my work.
Okay, so what do you do for the nuclear thermal propulsion?
So what I'm working on, which is my thesis
Okay.
work, is developing an integration framework so that we can more easily integrate the system.
Okay, what is it? Is it in the back of your mind that the work I'm doing as part of my education could end up being the final design for a nuclear thermal propulsion system that takes a human being to another planet? Is that in the back of your mind? Do you think about that?
It's creeping up a bit more as I.
But that's pretty cool. I mean,
Yeah.
so few people get to do things like that when they're in college.
Yes. As I share more with other people what I'm working on, and they're like, "Oh, I can use this for that. Oh, I could use this for this." It's becoming more real to me what it could be.
Okay, so in what you're doing, you're getting to see the nuclear propulsion project from you can take a step back and look at the whole thing, can't you? And what you're doing, as opposed to the folks who are just modeling one small part of it. So, gonna work. Dr. Thomas would like you to say yeah.
Yeah.
But I
Yeah.
mean, do you see, when you're doing something like this, doing a project in college, do you start saying, this is coming together? Do you have those kind of thoughts?
Yeah, it's been coming together more recently. I've been making a lot more progress.
So in your mind, do you think, yeah, this is we're gonna get people places using this stuff?
And faster.
Do I now?
And faster.
And faster. Yeah, faster. And Dr. Thomas and I talked about all the about all the good things about nuclear thermal propulsion, mostly not having to figure out how to carry big tanks of fuel to somewhere else. So you were good. You chose to be an engineer. Do other people ask you about what you're doing, and maybe should I do this, or what do you like? I mean, I know you. I've got to believe there are undergraduates who want to know if you're happy doing what you're doing, if it was the right thing to do. I mean, college students are always trying to make sure they're doing the right thing. Sometimes they don't do the right thing or major in the right thing. But do other students ask you?
I don't have that much experience or interactions with undergraduates at this point, since I'm not usually on campus, and since I'm only working on my thesis, I'm not taking any courses right now. So I haven't.
Okay, let's pretend I'm an undergraduate and I'm thinking, that looks pretty interesting what you're doing. How would you try to convince me that this would be something good for me to do? Are you thinking, Steve, if you had to ask, you shouldn't be one anyway? But I mean, you obviously like it.
Yes.
And there's got to be a reason why you like it. If you're going to boil it down to the reason why you chose to go on and get your master's, what would it be?
I like creating things, not even just in an engineering aspect, but I've always been creative, and like I make jewelry and I do art, and so I like creating, and that's one of the things. You can create a system.
Okay. So you can create, and there are a lot of people that you said STEM, but they say STEAM, adding the art to it. Am I correct that there is art in the whole idea of designing?
Definitely.
Designing something.
Definitely.
So is that something did that just occur to you, or did you realize, I'm creating here? Was that?
Yeah, I hadn't thought of it that way until I just did.
but do you see that though? Is that something you see that I'm creating, and this is, when you create something out of nothing, that is always art of some sort.
Yes, and when you finally get that final piece, it's like,
Okay, now you're going to go ahead and get your doctorate, you said. Will that also be in systems engineering?
Yes, it will be.
Okay, so why? Why are you going to go on it? Is it this answer will set up my next question.
Okay.
But why do you want to go ahead and get your doctorate?
Well, to be completely honest and transparent, since I'm working as a graduate research assistant, my tuition is covered. That's the main.
So might as well stay in.
Yeah, while I can and while I don't have any.
Will it be a doctorate in systems engineering?
Yes, it will be.
Okay.
So why
visualize
systems?
yourself? I don't know how long it takes to get a doctorate, but a couple of years down the road.
Yeah.
Do you know do you have an idea what you would like to do with your education experience?
I don't. Even graduating with bachelor's, I didn't imagine myself getting my master's.
Yeah.
Not that I couldn't do it, I just hadn't thought of it.
Okay. Well, but it's safe to say that you want to do something where you're creating or building working on something big.
Yes.
And like nuclear thermal propulsion is pretty big, but there are
big.
a lot of big things out there that haven't been built or designed yet.
Mm-hmm.
Is that what you want to do?
That would be amazing.
Okay. So, in your career so far, in your education, what was the biggest challenge for you? Was there a big challenge? Did you have trouble with anything? See, if you asked me that when I was in college, I said math. But you're good at math. But was there any course or any part of it that's been hard?
Some courses are difficult, like.
My dad said thermodynamics was really hard.
Yeah.
Is thermodynamics real hard?
Yeah, thermodynamics. I took that during COVID.
Oh yeah, let's talk a second about that.
Yeah.
Part of your education, you told me your sophomore year, as you progressed along. Your sophomore year was done remotely because of COVID.
Yes.
Not your most favorite year in college.
No, it was not good. So COVID broke out around spring break during
Yeah.
freshman year. And so we all had to go back home. And yeah, the entire sophomore year was remote. All the classes were on Zoom. And it was not a good experience for the professors or the students.
Well, and am I correct in the teachers around here that they much prefer classes that are interactive?
Yes.
And so as a student, did you want to raise your hand? I know you could probably ask questions, but but it's just a different, being there is the big deal, isn't it?
Yeah, and I really learned that I'm a better student in person. And
Okay.
I'm not a student that typically raises their hand. I'm very shy and reserved, and I don't.
What happens if there's something you don't know?
I'll go like after class
Oh,
or
okay.
send an email.
Dr. Thomas,
Yeah.
could I ask one little
Yeah.
question? Okay.
I'm more of that type, but yeah. So after COVID, I tried to take as many in-person classes as possible because
Okay.
it was easier to learn.
Okay.
And there aren't any distractions when you're in class.
Okay.
Because if I'm on Zoom, I could be on my phone
Oh.
or, yeah.
Did you? Okay. All right. People are listening, relating to that. All right. Model-based systems engineering. That's your world. Am I right?
Yes.
Okay. Can you imagine doing it any other way than doing it digitally, doing it the way you're doing it, or it's being done? Can you imagine doing it the old way with paper and stuff?
No, I could not imagine doing what I'm doing right now by hand.
Can you see any
No.
reason? Can you see any reason to do it that way? I mean, to you, of course, this is your world. It probably seems not easy, but why would do you ever say why would anybody ever want to do it in the old way?
Yeah. I don't know why.
So is your feeling? You're a student. You're working on your master's. You're planning to get your doctorate. Would you say that MBSE, model-based systems engineering, is the future, which we're kind of doing, which we are doing now?
Yes, it definitely is. There's a big push for it in academia and in defense as well.
You think is that good? Why would you say is that good?
I think it's good. It depends. They say that every model is not a good model. And so building a good model, whatever that means, is difficult.
Well, let me ask you this: but the way, as a collaborative, integrative process, that's how you determine if it's a good model, isn't it?
Yes.
Okay. So that would be that would be part of model-based systems engineering, figuring out what's the best thing. Mm-hmm. And you're an advocate.
Yes.
We're doing a little advertising for MBSE. Right?
Okay. Yeah.
But if Dr. Thomas said, what do you think is the best thing about it, model-based systems engineering? What would you say? I'm asking you these questions where I expected you to have thought about this at length and first time you heard the question. Would you say that would you say model-based systems engineering is the way to go?
I would say it's definitely way better than the traditional document-based because you can easily automatically update your models and it's readily available to everyone on the team. I think that's was a big issue with the document base. There would be a change made on this document, but it wouldn't be copied over to another document and maybe a page got lost or something. But if you're doing model based, that's easier to share information.
Yeah, and how important is it? I mean, the team concept in engineering. One engineer I wouldn't think that can accomplish a lot. Accomplish things, but it's a team process, isn't it? Pretty much all engineering is a team process.
Yes, absolutely, 100%.
And digitally with math, let's just pretend you're not that great at math, but you're computer savvy folks doing engineering as a team on computers. That's about as quick as it gets, isn't it?
Mm-hmm. I would say so.
Okay, so having fun?
Yes.
All right. Looking forward to working on your doctoral thesis?
I gotta get done with this.
Okay.
This
Have you even
master's
thought about
one
what a
first.
doctoral thesis might be?
It might be a continuation of what I'm working
Okay.
on. That would be the best route instead of completely switching to something different. And there are some things I could add to what I'm doing now to make it even better.
Okay, so, and you'll be helping human beings get to Mars faster.
That's the plan.
That's the plan. Well, all I can say is study hard and make us proud. Thank you for being with us.
Mm-hmm.
And thank you for being with us here on Digital Works TV. And don't forget, it works.